Section 600.32 C of the National Electrical Code addresses splicing requirements for field-installed flexible cord and cable used in sign and outline lighting systems. This section mandates that all splices must be made within a specific type of enclosure to ensure electrical safety and prevent potential hazard. The NEC explicitly requires these splices to be contained within either a metal outlet box or an approved splicing enclosure. The term approved splicing enclosure is key here. It signifies that the enclosure must be specifically listed and labeled for the intended purpose of splicing high-voltage cables, such as those used in neon sign applications. These enclosures are designed and tested to contain the high voltages present in these systems, providing a safe and reliable connection point. The requirement for using metal outlet boxes or approved splicing enclosures stems from several factors. Firstly, these enclosures provide a physical barrier that protects the splice from environmental factors such as moisture, dust, and physical damage. This protection is crucial for maintaining the integrity of the connection and preventing premature failure. Secondly, metal outlet boxes and approved splicing enclosures offer a degree of shielding that minimizes the risk of electrical interference or unwanted radiation. This is particularly important in sensitive electronic environments where stray electrical fields can disrupt the operation of other equipment. Thirdly, and perhaps most importantly, these enclosures provide a level of safety for personnel working on or near the electrical system. In the event of a fault or installation breakdown, the enclosure helps to contain the arc flash and prevent accidental contact with energized components. It is crucial to understand that not all enclosures are created equal. Using a generic electrical box that is not specifically listed for splicing high-voltage cables can be a serious safety hazard. These boxes may not have the necessary insulation, spacing, or construction to safely contain the high voltages present in neon sign systems. Furthermore, using an unapproved enclosure can void the equipment's warranty and potentially create a code violation, leading to fines or other penalties. When selecting an approved splicing enclosure, it is essential to look for a listing mark from a recognized testing laboratory such as UL or ETL. This listing mark indicates that the enclosure has been tested and certified to meet specific safety standards for its intended application. The listing mark will typically be found on the enclosure itself, along with other important information such as the voltage rating and the manufacturer's name. In addition to using the correct type of enclosure, it is also important to follow proper splicing techniques. This includes using appropriate connectors or splicing methods that are rated for the voltage and current levels involved. The splices must be made in a way that ensures a secure and reliable electrical connection, minimizing the risk of overheating or arcing. Furthermore, the splices must be properly insulated to prevent accidental contact with energized conductors. In some cases, it may be necessary to use specialized high-voltage connectors or splicing kits that are specifically designed for neon sign applications. These kits typically include all of the necessary components, such as connectors, insulators, and sealing compounds to ensure safe and reliable splice. When working with high-voltage electrical systems, it is always important to follow proper safety precautions. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and energizing the circuit before performing any work. If you are not qualified to work on high-voltage electrical systems, it is best to call a licensed electrician who has the necessary training and experience. The NEC provides specific guidelines for installing and maintaining electrical systems, and it is important to follow these guidelines to ensure the safety of yourself and others. Violations of the NEC can result in fines, penalties, and even legal liability in the event of an accident. In summary, when splicing field-installed flexible cord and cable for sign and outline lighting, NEC Section 600.32 C mandates the use of either a metal outlet box or an approved splicing enclosure. This enclosure must be specifically listed and labeled for the intended purpose of splicing high-voltage cables. Using an unapproved enclosure can be a serious safety hazard and can result in code violations. Always follow proper splicing techniques and safety precautions when working with high-voltage electrical systems. Look for a listing mark from a recognized testing laboratory to ensure that the enclosure has been tested and certified to meet specific safety standards. By adhering to these requirements, you can ensure the safety and reliability of your neon sign installations. It is vital to select the correct splicing methods and materials that are compatible with the GTO cable's voltage and insulation requirements. The GTO, or gas tube oil, cable used in neon sign installations requires specialized handling due to the high voltages it carries, typically ranging from 2000 volts to 15,000 volts or even higher. Selecting the wrong splice can lead to insulation breakdown, arcing, and potential fire hazards. The splicing enclosure needs to provide adequate insulation and prevent moisture ingress, which can compromise the insulation and create a path for current leakage. There are various types of splicing enclosures available, including those made from metal and those made from non-conductive materials. Metal enclosures must be properly grounded to provide a safe path for fault current, while non-conductive enclosures rely on their insulating properties to prevent electrical shock. The choice of enclosure depends on the specific application and the environment in which it will be used. For example, in damp or wet locations, a watertight enclosure is essential to prevent moisture from entering and causing corrosion or electrical problems. When making splices in GTO cable, it's also crucial to maintain the cable's original insulation level. High voltage splices often involve using silicone-filled connectors or heat shrink tubing designed for high voltage applications. These materials provide excellent insulation and help to seal the splice against moisture and contaminants. The quality of the splice is critical to the overall performance and safety of the neon sign system. A poorly made splice can become a point of failure, leading to flickering lights, reduced brightness, or even complete system shutdown. Regular inspection of splices is recommended to identify any signs of deterioration such as cracking, discoloration, or corrosion. If any issues are found, the splice should be replaced immediately to prevent further problems. In addition to following NEC guidelines, it's also important to consult with the manufacturer of the neon sign equipment and the GTO cable to ensure that the splicing methods and materials used are compatible with their products. The manufacturer's recommendations may provide additional guidance on best practices for splicing GTO cable in their specific systems. Proper training and certification are essential for anyone working with high-voltage electrical systems. Electricians and technicians who install and maintain neon signs should receive specialized training on the safe handling of GTO cable and the proper techniques for making high-voltage splices. This training should cover topics such as electrical safety, grounding, bonding, and the use of personal protective equipment. Furthermore, it is also important to consider the accessibility of the splice enclosure. The enclosure should be located in a place that is easily accessible for inspection and maintenance. It should also be protected from physical damage, such as being struck by vehicles or equipment. If the enclosure is located in a hazardous location, such as a flammable or explosive environment, it must be specifically rated for the type of environment. Hazardous location enclosures are designed to contain any potential arcs or sparks that may occur within the enclosure, preventing them from igniting the surrounding atmosphere. The NEC also addresses the issue of abandoned cables. If a neon sign is removed or replaced, any unused GTO cable must be properly terminated or removed. Abandoned cables can pose a safety hazard if they are left energized or if they are not properly insulated. The NEC requires that abandoned cables be disconnected from their power source and either removed or terminated in an approved manner. In some cases, it may be necessary to install a warning label on the abandoned cable to indicate that it is no longer in use. The NEC also provides guidelines for the grounding and bonding of electrical systems. Grounding is the process of connecting electrical equipment to the earth, providing a safe path for fault current to flow in the event of a short circuit. Bonding is the process of connecting different metal parts of an electrical system together, creating a low impedance path for fault current to flow. Proper grounding and bonding are essential for preventing electrical shock and minimizing the risk of fire. The NEC specifies the size and type of grounding and bonding conductors that must be used in different applications. It also provides guidelines for the installation of grounding electrodes such as ground rods and ground plates. Regular testing of grounding and bonding systems is recommended to ensure that they are functioning properly. This testing can be performed using a ground resistance meter or an impedance tester. If any problems are found, the grounding or bonding system should be repaired immediately. The NEC is constantly evolving to keep pace with changes in technology and safety practices. It is important to stay up to date on the latest revisions to the NEC to ensure that your electrical installations are compliant with current standards. The NEC is typically updated every 3 years, and it is available for purchase from various sources, including the National Fire Protection Association and online retailers. In addition to the NEC, there may be other applicable codes and standards that apply to neon sign installations. For example, local building codes may have additional requirements for the installation of electrical equipment. It is important to check with your local authorities to determine which codes and standards apply to your specific project. The use of qualified and licensed electricians is essential for ensuring the safety and compliance of electrical installations. Licensed electricians have the necessary training and experience to perform electrical work safely and in accordance with applicable codes and standards. They are also required to maintain continuing education to stay up to date on the latest changes in the electrical industry. When hiring an electrician, it is important to check their credentials and ensure that they are properly licensed and insured. You can also ask for references from previous clients to get an idea of their quality of work. In conclusion, the splicing of GTO cable in neon sign installations is a critical aspect of electrical safety and code compliance. Adhering to NEC Section 600.32 C and utilizing approved splicing enclosures along with proper splicing techniques and materials are essential for ensuring a safe and reliable neon sign system. Regular inspections, maintenance, and the use of qualified personnel are also important factors in maintaining the integrity of these installations.